Hey everyone, so in our next section we're going to move on to multiplying and dividing rational expressions. So far we've really just been evaluating them, simplifying them, and then stating those non-permissible values. So just kind of recall that when we take our regular numbers that don't have any variables with them, and we multiply fractions, we always multiply straight across the top, and then we multiply straight across the bottom, and that gives us our fraction. So our 2 times 5 value and our 3 times 9 value. Just move forward in each one, which then give us our answer. And then after that, we need to evaluate if we can simplify that. 10 over 27, can it be simplified? And in this case, the answer is no. So we treat rational expressions the same way. We multiply across the top, multiply across the bottom. So for instance, here we have 14 over 9 and 6 over 7. And so what we can kind of get in the habit of doing is we can get into this habit of evaluating these before we multiply them. You can certainly reduce them at the end. There's nothing wrong with being able to reduce at the end. It's helpful when you go through and see them if you can cancel things out early. So basically, what this is saying is it's 14 times 6 over 9 times 7. Now, we can take the 14 and the 7, and you can see that 14 divided by 7 gives us 2. So in this case, I can actually cross out this 14, and I can say that 14 divided by 7 makes 2. So it means 7 divided by 7 just makes 1. I can also do the same thing with the 6 and the 9, and maybe we'll just take this step by step for the first example and show you that what's left over here is really 2 times 6 and 9 times 1. You see how 14 over 7 reduced down to 2 over 1. Now with the 6 and the 9, I can do the same thing. Both of them go into 3, so I can do 6 divided by 3 gives me 2, 9 divided by 3 gives me 3. So really what I have here is I have 2 times 2 over 3 times 1, which just gives me 4 over 3. Now, you could turn and write that into a mixed fraction. We're not going to go through that step. It's mostly just to simplify down to its lowest term. So let's take a look at our next one now where we start to have some variables put in here. We have a 4x squared times a y squared, and we have a 3xy times an 8x. So if I were to combine everything together here, I'd have 4x squared y squared. I can't do anything with the top. And the bottom part, 3 times 8 gives me 24. And then I've got x times x, which is x squared. And then I've got a y term after that. So hopefully now, the same way that we did the 14 and the 7 above, you can kind of see, okay, I can simplify this a little bit because I have x squared terms that are going to cancel out. And I also have a y squared term on the top and a y on the bottom, which means one of the y terms on the top is going to cancel out with the y term on the bottom. That's going to leave me, in terms of my variables, and again, we're just taking this one step at a time, a 4y on the top and a 24 on the bottom. Notice that the x squared and the y both disappear in the denominator spot. So now I take a look at my number, 4 over 24. They both go into 4 evenly. So 4 divided by 4 is 1, and 24 divided by 4 is 6. So really, at the end, this just gives me y over 6 as a final value. In my last expression, same thing here. I've got a 3a cubed multiplied by 16b cubed all over top of 4b times 27a. I'm going to multiply those together and see what I can come up with. Or maybe first, before we get to that step, maybe you can see something that can cancel out early. And so if we can get to this point, that would be great because it saves a lot of extra steps afterward. So do we see here that we have an a cubed term, okay, we have an a term, so I can cancel out my a term, and that cubed is going to become a 2. Now, same thing with the b, I can cancel it out, and this cubed is going to become a 2. So, okay, I've taken care of my variables, and they've kind of reduced down, we'll say, as low as they can go. So I'd have a 3a squared times a 16b squared over top of, and I've got 4 times 27. Now I haven't combined these yet, 3 and 16 and 4 and 27. We certainly could. You get 108 on the bottom, 48 on the top, and then you just reduce that fraction. But hopefully what you can see out of this is that 3 actually goes into 27 and 16 goes into 4, so I can actually simplify it before I combine it. 3 goes into 27, and 27 is divisible by 3, so 3 divided by 3 is 1, 27 divided by 3 is 9, and 16 divides into 4 evenly. 16 divided by 4 is 4, and 4 divided by 4 is 1. So I can actually simplify my terms here, and really I just have a squared on the top and 4b squared over 1 times 9. That simplifies quite a bit. So now all it's left over is a squared, or sorry, I have to put my number first, 4a squared b squared over 9. So I can simplify this before I combine those terms, or I could do it afterward. Because again, what we would have got on the top would have been 48, and on the bottom would have been 108, and then I just would have had to reduce that fraction down to its lowest terms, in which case I still would have got 4 over 9 as a value. But if I see it early, that might help in simplifying it a little bit easier, maybe without the need for a calculator. So when multiplying rational expressions, first we need to factor the numerators and the denominators, and then divide by any common factors. Then we express the product as a simplified rational expression. So in this case, now we have our variable set in place, which means we also have these non-permissible values, so it's connecting back to a previous video on simplifying rational expressions, and we're still going to treat this the same way. So I have 3x squared times 5ab, okay, 3x squared times 5ab over 2a times 6x. Now, what can combine here, or what can simplify? Well, it looks like I have an a term that I can cancel out, and I have an x term that can reduce the power of this to 1. And so what can be left over with this? In our next step, it looks like I have 3x times 5b over 2 times 6. Now again, I can reduce this down. I'd have 15 over 12, or maybe we see that this 3 divided by 3 is 1, and this 6 divided by 3 is 2, can make a smaller term and maybe make it a little bit easier to see. So really, I have 1 times 5b over 2 times 2, which is really just the same as saying that I have 5b over 4. Now, up until now, we haven't talked about restrictions. So let's take a look and see what we have for restrictions here. So I have my simplified answer, and I need to know my non-permissible values. So it looks like 2a can't equal 0, which means a can't equal 0, as well as I've got 6x, so 6x can't equal 0, which means x also can't be 0. So a cannot equal 0, and x cannot equal 0. So I have 2 non-permissible values here. All right, let's take a look at another example. So in this case now, hopefully you're seeing, okay, we're going to need to factor this in order for it to work. So x squared minus x minus 20. I'm going to start with that, and we're going to factor these out one at a time. So the first term here, I'm looking for 2 things that multiply to give negative 20 and add to give negative 1. So I have x minus 5 and x plus 4. Right, they're going to multiply out, and I could FOIL that out and get my original expression back. On the bottom, I have 2 perfect squares separated by a subtraction sign. It's a binomial term, so I have a difference of squares, x minus 3 and x plus 3. On my other side, I have an x minus 3 term. I'm going to tuck it in brackets just because I want all of my expressions to kind of stand out. And on my denominator spot on my second term, I have two things that need to multiply to make 8, and then they need to add together to make 6. So it looks like 4 and 2, x plus 4, x plus 2. And then when I take a look and I see what this could be, I can see right away that I have an x minus 3 term that can cancel out top and bottom, so x minus 3. I also have an x plus 4 term that can cancel out top and bottom. And so it looks like what will be left over at the end will be x minus 5 over x plus 3 and x plus 2. Now, when we state our non-permissible values for this, remember that we have to go for every example, not just our final answer. So really, if I were to take a look for non-permissible values and I'd go back, I'd have to identify everything that's in the denominator spot to see what a non-permissible value could be for it. So it looks like in this case, x cannot equal plus or minus 3, x can't equal negative 4, and it also can't equal negative 2. So I'd have my solution, my simplified answer, as well as my non-permissible values. So hopefully maybe you have a handle on how this looks. So what I'll get you to do is to try the next one on your own and see if you can simplify or work it out, and come back when you're ready and we'll go through the answer. Alright, so I'm going to start this the same way. I'm going to go through and I'm going to simplify my expression. So I have a 5, looks like can go into each one, and then I'll have an n plus 3. And then on the bottom it looks like I have a 2, that's in common, and I have a d minus 4. And then on the top on the other side looks like I have a 3, and then I have a d minus 4. And on my denominator on the other side, looks like I can factor a 4 out there. And then I have an n plus 3 left over. So if I were to take a look and see what can cancel here, d minus 4s look like they can cancel, n plus 3s look like they can cancel. And then if I look at my numbers, it doesn't look like I have anything in common between them. So if I multiply them together, 5 times 3 gives me 15. I don't have any terms left on the top. And 2 times 4 gives me 8, and I don't have any terms left on the bottom either. So then I need to state some non-permissible values for this. So again, I just need to look in the denominator spot to see what my non-permissible values would need to be. It looks like d cannot equal 4, and it looks like n cannot equal negative 3. And again, those come about just because we say this term, n plus 3, cannot equal 0, which means n cannot equal negative 3, right? Just subtracting 3 over to the other side. Same thing here, I'd say d minus 4 cannot equal 0, and so then d cannot equal 4. Okay, so all we're doing is taking a look at the denominator, and we're just checking and seeing what it can't be. So that's our idea for multiplication.